And for example 3, we also need to learn about multiplicity. So the new definition, sometimes you get an x-intercept that happens more than once. So for example, if you had this equation and you factored it, you would get x minus 1 times x minus 1. I can write that right above. Yes.
Karen's email is pretty specific about department heads only preparing that list. Do you want to let them know that you're
I'll let them, I'm going to let them know, but then what, he just didn't want emails from everybody.
Yeah.
Yeah, that's the only reason. So if you write it up,
Give it to you.
yeah, perfect, and then I'll send it in. Okay, so if you factored it this way, and you're like, oh, what are my x-intercepts? You would get x equals 1 twice. So what we're going to say is we're going to say that that is a root or a 0 with a multiplicity of 2, because it happened twice. So the word multiplicity is just used for how many times does an x-intercept show up in the factors. Does it show up more than once? Then it has a multiplicity of a number bigger than 1. Like this one, apparently it factors perfectly to x minus 1, x minus 1, x minus 1. So you would get the x-intercept of 1 3 times, and we would say it has a multiplicity of 3. Now something interesting happens when the multiplicity is bigger than 1. Most factors only happen once. In fact, the graph that we just did, can you see that all of these factors, there's one of this one, one of this one, one of this one, one of this one. They all happen once. Most of the time, they happen once. But sometimes they happen more than once. And when they happen more than once, we have the following things happen. So with an even multiplicity, like in a parabola, it just so happens that the vertex is right on the x-axis. And with the x minus 1 cubed, with the odd one, that's like a regular x cubed graph. This is what happens at those x-intercepts. So we're going to summarize this off to the side. We are going to start with an even multiplicity. So that means the x-intercept happens an even number of times, like in the parabola. And what happens? Just like a parabola, instead of the graph going through the x-intercept, the graph is going to bounce off the x-axis at the x-intercept. Okay? Bounces is in quotation marks because I don't think that's an official mathematical term. But I think it describes what's happening the best. If you have an odd multiplicity, in other words, the x-intercept happens an odd number of times. And you can see this by like the exponent of that factor. If the exponent of the factor is even, then that x-intercept is going to happen an even amount of times. If the exponent of a factor is odd, it's going to happen an odd number of times. And if the multiplicity is, there's two situations here. If the multiplicity is 1, the graph goes straight through. This is what we've had every single time. Straight through the x-intercept. if it is larger than 1, 3, 5, 7, dot, 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 anything larger than 1, the graph bends, or sometimes people like to call it it bends or flattens out at the x-intercept, much like an x-cubed graph. There's my x-intercept. An x-cubed graph has that bend in the graph right at the x-intercept. It bends so much that it's basically flat for a moment at that x-intercept. So that's why some people like to say flattens out, because it does get, for a second, perfectly flat and then bends down the other way. This is going to be important as we get to example 3 here. The nice thing about example 3, if we wanted to graph this, we're still using the same steps as before. So we still need to know the end behavior. And because it's factored out, we sort of have to temporarily multiply it out. Can you see that if you multiplied this out, you would get an x to the 5 graph? How do I know it's going to be an x to the 5 graph? Because I have 4 x's there and 1 more x there, and if I multiplied all of those out, 4 x's and 1 more x, that will give me 5 x's in total. This will be an x to the 5 graph. An x to the 5 graph is odd, so it's going to act like a line with a positive slope. Because the x to the 5 here, you also have to tell that it's going to have a positive in front of it, a positive 1. So that's our end behavior. Y-intercept is a little trickier when it's factored. Not really tricky, but not. You would plug in 0 for x. And here you'd have 1 to the 4 times by negative 2 to the 1. Happens to be negative 2. So our y-intercept is at 0, negative 2. And our x-intercepts are easier because it's already factored for us. Plug in 0 for y, and you have x plus 1 to the 4 times x minus 2. Since it's already factored, you've got your x-intercepts right away, and what we notice in this one is because that exponent is 4, this one has a multiplicity of 4. So our two x-intercepts are negative 1, 0, and 2, 0. And now we can use all of our x-intercepts and y-intercepts. To draw this graph. I know that I have an x-intercept at negative 1, a y-intercept at negative 2, another x-intercept at 2. So again, I label these points, and I know that my end behavior starts down here and ends up here. Now some rules. When you find your x-intercepts and y-intercepts, you cannot add any more x-intercepts. Okay? So a number one mistake that's sometimes done in this one is like, okay, I'm going to go through this point, through this point, through this point. This is bad because you see that I added another x-intercept there. So I need this to go away. And we need to redo it. This multiplicity of 4, this tells us it's an even multiplicity, there's going to be a bounce. So if I'm coming from down here, When I hit this one, I gotta bounce off. This one has a multiplicity of 1. 1 just goes straight through. No bend, no bounce. And this is how multiplicities work. So I'm going to get you to try part B on its own, but we're going to first of all just start it. See if you get, I want you to figure out the end behavior of part B. And do you see that x equals minus 1 has a multiplicity of 3? And that will be a bend. For the end behavior, if you multiply this out, you're going to get x cubed times x. You're going to get an x to the 4, but with that negative, it'll be a negative x to the 4. So your end behavior is going to act like that. Questions for practice? 9, 10, 11, and 12.